What's good, everybody? In today's video, we're looking at 5 key problems on how to simplify radical expressions that are fractions. To start this video off, guys, there are 2 key things we have to understand. One, how to simplify radical expressions, and two, how to get rid of radicals in the bottom of a fraction. But before we go there, let's just understand what this expression is saying. So we could split this radical, right? And keep them separate instead of having it as one whole radical. And it makes the problem simple. So now we're saying, hey, we're trying to find out if we could simplify radical 9, which we can, and radical 100, which we can. So my answer would just be 3 over 10. Now let's say if we went over the variables, right? Understand the variables follow the same principles. So when I split this problem, I'm going to have radical x over radical y to the fourth. For us to be able to simplify this top radical, it has to at least have a power of 2. Because it doesn't, we can't simplify it. It's going to stay the same. But when we go down to the bottom, we could simplify this and we would get y to the second power, and this would be our final answer. However, in our next 3 problems, it's not going to be that simple. What's going to end up happening is that we're going to have to now rationalize the denominator, and I'm going to show you how to do that. So our first example, we split this, we're going to get radical 20 over radical 27. When I simplify this more, my top is going to turn into radical 4 multiplied by radical 5 all over radical 9 times radical 3. Now understand, we can simplify, and that's what we're going to do. So I'm going to get 2 radical 5 on top all over 3 radical 3. Now, guys, just understand that we cannot leave it like this because there is an irrational number in the bottom of the fraction, which is radical 3. So to get rid of it, we're going to multiply by radical 3 at the bottom and the top. So now on the top, we're going to have 2 times radical 15 all over 3 times 3, which simplifies to 9. So my final answer would be 2 radical 15 all over 9, and that's it. But let's say we go into our next example. And then our next example now is something different. Oops, same color marker. So now let's say we had this problem. Let's see. Oops, let's rewrite this. Looks ugly. All right, so radical. All right, so now first thing I do, and guys understand you don't have to split it if you don't want to, but I like to do it to keep it simple. So now that I separate those radicals, I can simplify it a little bit easier. Luckily for us, we've done radical 27. We know it's 9 times 3. And then for radical 8, we could simplify that with 4 multiplied by 2, right? Always want to use your largest perfect squares to simplify radicals. Now when I simplify, the top is going to turn into 3 radical 3. And on the bottom, I'm going to get 2 radical 2. Similar to this problem, we cannot simplify this. So as a result, we have to rationalize the denominator. So I multiply by radical 2. And now what I get on top is 3 times radical 6 all over 2 times 2, which just simplifies to 4. Because when we multiply the radical by itself, we're just going to get that number without the radical. So this is how we get 4 on the bottom. But before we go, really hope you have enjoyed this video. I ask that you smash the like button for us. I got one more key example. And this example is a lot different from these two because it's going to give us one more additional step that we have to take. All right, so here goes the problem. So we have radical 50 over z to the 5th power. So how are we going to do this? Guys, it's the same exact process, same exact steps. So once we start off, we're going to split it. So I got radical 50 all over radical z to the 5th. We're going to have 25 times 2 on top. And because we have an odd exponent, we're going to split it and have the highest even exponent by itself. So that means I'm going to have z to the fourth power multiplied by z. When I multiply these two back, it'll give me z to the fifth. Now it's time to simplify. So our top turns into 5 radical 2. And then on the bottom, z to the fourth comes out from under the radical and turns into z squared. And that other z stays under the radical. Now, similar to the other previous problems, we cannot have this radical in the bottom. So I'm going to multiply it by itself and do the same thing in the top. So as a result, I have 5 times radical 2z all over z squared times z. So now this is the last additional step, combining properties of exponents. And for our final answer, what we should get, put it right here, top stays the same, right? 5 times radical 2z, and then on bottom, this is going to turn to z to the third power. So when we're talking about simplifying radical expressions that are fractions, please remember that you have to rationalize it if there is a radical in the bottom of the fraction. And we really hope this video review was helpful for you guys. Smash the like button for us, subscribe to the channel, hit the bell notifications, and leave questions or comments for future videos you guys would like to see on our channel or on this video. Thank you guys so much for joining us today.